Hi. Today we are going to see post estimation. Okay. Post estimation is one of the targetable action moments where we are going to see in computer visions. Okay. And previously we have seen Imran is teaching image classifier under the computer vision. So after image classifier, post estimation is the second thing we are going to see on computer vision. Okay. And what is post estimation? Okay, and I just give a little demo. And could you able to see?
Yep.
Could you able to notice what is really happening now?
Yeah, yes. The coordinates we
Okay.
can see.
Okay. These are the key points. Actually, this is what post estimation is. Okay, and now we can. Okay, now we can kickstart what is post estimation in a theoretical way. Okay, and before that, I've seen an amazing blog which is from Viso.ai. These guys built a wonderful computer vision applications, okay, with integrated thing. But this is not open source actually. But when it comes to blogs and the information they have, it's like quite amazing. Okay, so anybody can have a clean picture about what is computer vision and what is image classifier and the tools and neural networks and so on. Okay, and right now, what I've shown you in the post estimation is a 2D post estimation. Okay, so where this post estimation is applied, it's like we can understand the body languages of a patient or body language of the sports personalities, and we can under work personalities and construction workers and anyone. Okay, so through this, like we can understand what is really happening around uh, the video or rendering through live cameras and so on. Okay, and this is an example. This is like multi-post estimation where previously you have seen few videos like if Imran has done this, and where you could see like there will be a box image one person, two person, three, like in a box, like image classifier on object classification, it be shown in a this way. Okay, but here in post estimation, like we can identify a person with the key points and then which connecting with edges. Okay, so when we if we building an third party APIs and then we running a post estimation, and we could design our own post estimation for a school cricket team or a college or university sports team, or like exam notions of our students. Like we can understand such no points and we can build our own conditions, and we can build our own post estimation applications for them. Okay, and when it comes to post estimation, there are two things. Like one is human post estimation, and other is like animal based post estimation. Okay, so when it comes to animal, we could also analyze the key points of animals as well as object post estimation. We could understand the cars and so on also. Yeah, here you could see the edge points of the cars and other objects too. Okay, and yeah, when it comes to post estimation, and what you have seen is like a kinematic. Okay, the demo I've shown is a kinematic. This is just a geometrical analog of post estimation where we connect the points. But this planar is like something which goes on both in 2D post estimation as well as like 3D post estimation. Okay, and the third one, it's like volumetric. Volumetric post estimation, it's like we understand, we do the post estimation on 3D way. Okay, we combine, for example, a few weeks back, we have seen anybody can talk like a Elon Musk, or anybody can talk like a Barack Obama, or anybody can talk like a Donald Trump, and so on. That is like basically used on deepfakes. So in the before achieving the deepfakes, volumetric post estimation is our alpha node to achieve the deepfakes. Okay. And as we see animal post estimation, so we just connect through understand the speed. When it comes to animal, how we can achieve the condition, we would design the key points, but through post estimation, we need to understand this is a dog, this is a cat, and this is a kangaroo, or this is an elephant. We can achieve through their characteristics of speed and body language, and we can achieve animal post estimation also. Okay, and this could also helps in nano robots, or the robots we be building, and so on. And right now, anybody can build your home-based, or your own post estimation by us through our pre-trained models. Okay, and to achieve the best part of post estimation, it's like we need to understand the key points, what each and every key points means, and what is the purpose, and what is really saying it. Through this, we can do a connection. And here you could see MS Coco data sets. Okay, this is one of the biggest Microsoft common object in context data sets, where they have a lot of most trained object oriented data sets. Okay. So now we kickstart. Today it's 2023. I found myself so lazy and I don't feel like coding. Okay, so what I do, it's like immediately I go Teachable Mission. It is designed by Google.
Reuben, we are not able to see your video. Maybe that other demo is running. Maybe if you can stop that, we can see your video. Yeah,
Okay.
we see you now.
Yeah, it's this is Teachable Mission. This is a Google-based most pre-trained models, and anybody can do image classifier, or anybody can do sound classifier and post classifier without any code. Okay, now I'm just going to show or demonstrate. I wanted to do a post classifier. So what I do, it's like I want to play example stone paper scissors. Okay, so in the class I'm saying stone. So so I need to do a stone. So what I do, it's like every time when I show a hand of this thing, so I be like showcasing, building a data points for a stone. Okay, so that it classifies this as a stone. Now paper, what I do, it's like I need to show my hand like this. So this is a paper sign. So so I'm building a data set for a paper. So this is a sign for paper. So like so that it will identify as a paper. And then scissors. Okay, and what I do, it's like next thing I drain this data. So they inbuilt do the machine learning part and convolutional neural part, and they integrate all the TensorFlow models and so on. So it's easy, like I'm training my data here. If once it's done, I take so out of 50 images, taking a processing with 15, 16, so on. Yeah. once it's trained, I could able to see the models here. So what I do, it's like it accessing my post now. So you could see stone papers. So what I'm just showing you. Okay. So it can able to analyze it. So what I'm really just showing paper and then like stone. Okay, there's a problem with stone, I think. So maybe we need to train with huge data. So this is something easy for a person who can kickstart and they just do train the regular data. Okay, like a color based or like for example, if I'm having a cat kitten data. Okay, like if you take tiger family, even all the cat, if you take a cat family, even a tiger cub and panther cub and jaguar cub, even cat kittens and everything looks like based on cat. Okay, but we can easily say because we learn through information, like we can analyze it and we can say that this is a tiger cub or this is a lion cub or this is a panther cub. Okay, but in mission initial stage it won't do that. So but we could also train that kind of data, like I'm uploading a cat data and then here I'm in the name of paper I'm uploading a lion cub data, or in the name of sister I'm uploading a tiger cub data. So once I train here, it will show when I show the data for cat kitten or whatever it is. It's like it can showcase that this is kitten, this is a cat data, and this is a tiger based cub and so on. Okay, so now we get into MoveNet Lightning. This is a Python-based code. Okay, so here initial when it comes to code, like what we do, it's like whatever the ML code or deep learning code, it always contains with 4 strings. One, it's like initial stage we install and import dependencies. Okay, and the second thing will be like we load the model. Okay, and the third thing will be like it could be the make deductions or the requirement needed, the packages that you needed, and what you're really using it up, the analytics you'll be making. So you could say, and so on. But in post estimation, we could say we making deductions. Okay. And the third thing will be like drawing key points. What we, as I told you, key points is the major part of post estimation. So we need to understand the key points. So it's like we understanding a function. So we are building a own method and following the function to detect the deductions from our loaded model. Okay, so yeah, that's it. So how we can do this? Like, so here the requirement packages have been installing. So here I've been installing. I'm using pip. So it's an account of so Python based API thing. So where you integrating all the Python codes. So here initial stage I'm installing TensorFlow and then OpenCV Python and then Matplotlib. Matplotlib I'm installing Matplotlib for analyzing my data points of my images. Okay, and OpenCV Python here, what is the role it making? It's like I'm using OpenCV because to access my camera so that and also to make analytics prediction here. And TensorFlow here I'll be using to download my pre-trained models, where here you could see TensorFlow hub. So I'm just redirecting my loader model here, so it will call upon here. So here I'm installing TensorFlow, OpenCV, and Matplotlib right now. Okay. So here it says requirement already satisfied because I've already installed this dependencies. And now I'm importing dependencies now. Okay, once after made the installation, now I'm importing it out. So here, the role of a TensorFlow, it's like to make the deductions, and I'm using the loader fonts here. And then Matplot, the why NumPy here, there is no NumPy needed, but since I'm making a the array of functions, I'm understanding the points here. So like I'm going with NumPy here, and Matplotlib 2 is basically for my testing. Okay, and OpenCV to render my web camera. So I'm just importing now. So it's imported now. So the first after importing and installing your dependencies. Now I needed to load up my models. Okay, so when it comes to load up my models, you need to understand when it comes to post estimation, there is a TensorFlow who just help us with all the computer vision and NLP deductions. Okay, so this is one of the most globalized pre-trained models. So I'm going with TensorFlow Hub. Under the TensorFlow, like they have MoveNet. Okay, MoveNet is something which is targeted for especially object detection and post detection and so on. So they have an architecture like pre-trained models and so on. So when it comes to here, they have the input dependencies with the shape of like 192, 192 into 3. This is the shape of the images which is go the screen axis of your thing, and it's been RGB value and so on 0 to 255. And here you could see the speed of the here you could see the points. They have loaded key points like nose, left eye, left ear, right ear, and so on. So totally they are 16 key points. They have already pre-trained, Okay, so now it's easier to load the model. So here, how I'm just going to load the model, it's like I'm calling an interpreter function. So through this interpreter function, I'm calling a TensorFlow, which is already installed. So I'm using TensorFlow Lite and then interpreter model path. So I need to install the model path here. So how it's like here you could see downloaded. So once you click the downloader, it's just a small file you could download, and you can store the required dependency in your Jupyter notebook. Okay, so wherever your terminal of your Jupyter notebook is running, you need to run this file. Okay, once after you run this file, you need to call it call the path of the model here. It's the file name is like light model movement single post lightning 3 and T5. Okay, so here after that I'm calling an interpreter. Now I'm calling the preload allocator tensor. Okay, so tensor is nothing but this is one of TensorFlow model, where which use case with numeric form of all the matrix and data-based thing. So normally when we use on our own, we need to do a lot of code. So we'll be using NumPy arrays and so on. But when it comes to pre-trained model like TensorFlow and so on, we could easily use like Tensor. So here we calling already the alligator tensors here. Okay, now we need to make deductions. So to make deductions, so I need to access my camera. So here, there is a camera function. Uh, it's a it's a code like where we importing the NumPy, importing the computer vision tool, and then we need to capture a camera. So like here, there will be a cap is equal to computer vision tool or video capture is equal to 0. Okay, so here you could, if you using 0, then you using you can using your webcam. Okay, or else if using some MP3 file or a MP4 file, then you're accessing the video of already video of your gym or whatever it is, you can train over here. And then there is a condition where once after capture, it will render it and frame it. So, and then there will be a color grading, and then it's a showcase. And once we capture, we need to also have a command when to on the camera and when to off the camera. So here the Q button will be like to off the camera and so on. So that's what here the code is happening here. So I'm capturing the uh, capturing my camera. Once the video capture model is open, so it's capturing my camera, and then it's after that it's reading my captures, and then it will storing in the file, storing in the variable called ret and frame, and then I'm showcasing here the cv.in.show. It's like when I run the code, it showcase what is the name of the capture. So it will like moonlight lighting I've been naming. Here you can name Reuben like post detection or whatever it is. Okay, so you can name anything on your own, and that's it. So once after that, inside a thing we refer it as a reshape image or set up input and output conditions, and then make predictions. So separately, what I'm doing, it's like now I made it a capture detections. So the third thing I've been going with like to understand my key points. what is really concluding it up. Okay. So during the key point, I've already in the previous itself be collecting a data of frame, and then I'm building my own key points. Here in the TensorFlow hub itself, like they have their own key points and so on. So we are be calling it those hubs. Okay, so already it's a predefined code here. We just copy this TensorFlow code and we can run the conditions in the draw key points. And once after we draw the key points and we naming the agent, understanding the edges. So for no, here we understanding edges of the connections. So it starts with 0, 1, 0, 2, 1, 3, 2, 4, and 0, 6, and so on. What are the points really mean? It's like 0 refers to nose, and 1 is refers to left eye, and 2 is refers to right eye, and so on. And here the 16 is refers to right angle, and then 15 is refers to left angle, and so on. Okay, so that's what it refers. So understanding and connecting the edges of all the key points here. Once after this understanding, I'm building another connection. So it's like right now we created our key points, we created our edges. And the third thing is like we need to connect all those edges. So I'm building a function called draw connections. So here we already got frame key points and then edges. Now I'm building another variable called confidential threshold. So through frame, I'm calling y, x, and c as a variable. So you could also call that as a z or what z, so that in the axis of the scale, so we could call this frame variable. And once we done for every edge and color in edge item, so we can uh, these edge node points will join together under the name of P1 and P2. And then it will shape is like Y1, X1, C1 and Y2, X2, C2. And then the confidential threshold condition will call it up. So it will build a functions here. Okay. So now I've loaded a load model here, and I've loaded my key points here, and then I've loaded my edges here, and then I'm calling my connecting all my edges here with a line. So I'm concluding with my detection and then capturing my camera now. Yeah, could you able to see the screen? Camera open, sir.
We don't see the camera. We only see your Jupyter. I think one tab before there is the video is the camera is being used. One tab before this. Yeah, post model teachable machines is using your camera, right?
Okay. So yeah, now we can able to see it, right?
Yes.
Yes.
Yeah. So so this is called in frame. So this in frame I name it's like MoveNet not lightning. So as I said here, uh MoveNet lightning. So this frame I've been naming as a MoveNet lightning. So you can name any the name whatever you want. Okay. So so this is what you see here. It's like it's I'm sitting right now, so it can showcase this top-down post detection. It right now it's analyzing my face and the actions and so on. And now if I go some stand like so it can showcase draw the actions of my hands and so on. It's still learning. So like this we can build an application with the condition. For example, I wanted to train, we need to have our own AI-based boxing coach. We could also build an own AI-based boxing coach on our own. Okay, so like a boxing coach, a karate coach, or a dance tutor, dance dance trainer, and so on. Okay, and yeah, this is how the post deduction, the first part of a post deduction is. And any questions?
I have a question, Reuben. Hello, this is Uma.
Yeah, yes, Uma.
Actually, you showed the key points, right? Where did
Yeah.
we get that one? Like, how can we decide like nose is 0, like I is something else? So these key
Yeah.
points, where did you get from?
So yeah, in the TensorFlow Hub, you could able to see model card. Please see in the model specification. They will have a PDF file. Okay, you could see a model card here. Okay.
Oh, okay.
So
So
in the model card, you be understanding the paper documentation of this model. So here, what they say, it's like what they it's here they say it's a RGB image and predicts the human joint location. And
oh, okay.
they have two things. So one is called MoveNet single post lightning and MoveNet thunder. Okay, lightning is just a fast one. It will predict in 50 FPS speed. Okay, and thunder is actually 30 FPS speed. So if I'm working on with video or whatever, already predefined MP3 files and so on, I could go with 30 FPS speed. Okay, so once it's the data is trained, it will show the move points. But here I'm using 50 fps. So in a live, I'll be showing all the key points and the edges and connections about my post deduction. Okay, and if we scroll down, we could see about the frame, the input frames. It goes on with RGB value 0 to 55. And then the intro about the frame, it's 192, 192 into 3. Here, what we call as XYZ of the frame. Okay, and we combine we analyzing the allocated tensors here. Okay, and the more we scroll down, they have an information about the data where they trained and how they accessed it. And then they even mention about the key points. Yeah, if you see the output, the flow 32 tensor of shape 117 17.3, and here
Okay.
they have ranged it like it starts with 0.0 and then comma 1.0. Okay, so they already shared in the, he mentioned that in the order of nose, left
Yes.
eye, right eye, left ear. So they already mentioned the order of this. So in the notes itself, they have mentioned like here we're using nose as a 0. Okay,
Yes.
and if this is just a point, but I can say it's already in 0, but we could also build our additional key points like nose as a 0, 0.0, and then nose of right side is 0.01, and then nose of a left side is 0.02. Okay, we could also bring our own conditions here.
Okay. Okay.
Okay,
Yes. Yes. Thanks, Reuben. Thank you.
yeah. And my favorite of pre-trained models is like Hugging Face. So they have a lot of third-party pre-trained models here. Okay, you could see what for multi-model they have a feature engineering, text to image, image to text. Okay, and for computer vision they have a deep estimation, image classification, image segmentation. They have all the pre-trained models. The more we understand the paperwork and then documentation of the model, the more we can build anything through AI. And any questions?
I have a lot of questions, Reuben, but before I'll ask Kavita.
Okay.
Kavita,
Yeah, Arun.
can we have a open Q&A session, or shall we, because of time consideration for developers, because still this is being recorded, so the questions others can also see, because I think this is a nice opportunity. We can ask Reuben a lot of pertinent questions. What do you think, Kavita?
Yeah, I think like if people had to leave, I think they're free to leave. So meantime, because this is a recorded session, we can go ahead and yeah, you can pose your questions.
Okay. Reuben, how much time you got? Because I have a lot of questions for you.
Okay, I've got 15 minutes.
Okay, I'll try to wrap within that. So in the first teachable machines you showed, right?
Yes.
There is an export model, right?
Yeah.
On the top right preview export model. So after you on the right side card, yeah, there above there is an export model. Yeah. So basically you can train it and then you can export your model as a TF Lite file, is it?
Yeah. So here we could also use TensorFlow.js file, and I could also able to use my Hugging Face model also here.
Okay. And
So I
then
can bring my
the second example you showed, you actually loaded a model. Was that this model that you created, or is it a different model?
This is no, this model is I'm calling the TensorFlow model. Okay. Under the TensorFlow, there is a for live post deduction, and there is a model called MoveNet Lightning.
Okay.
So I'm calling. So here you could see MoveNet Lightning. So under the MoveNet, what I've shown it's a single post because I'm the only person here. So I need to showcase the single post. So I'm calling the single post Lightning. So what is Lightning? It's like it's an advanced version where it runs on 50 FPS speed.
Okay.
And they also have another version that is Thunder version. So Thunder version will work on 30 FPS speed.
So my question is, the second example, you used a pre-built model sitting inside TF and you used that.
Yeah.
In the first example, you created a model for rock, paper, scissors.
Yes, which is I didn't create any model now. I'm just using the third-party model here and I'm coding it. And I'm just training my data here. That's it.
No, but in teachable machines, it said export model. So have you actually created that model now?
No, nothing. I haven't created anything now.
Okay.
So if you want, for example, like as to say, normally if I train, I hope if you know boxing, right? So there is a jab, there is a punch, there is a so on. So in the instead of stone, I'm creating a jab. So whenever jab is like a different pose, and then punch is a different pose, and then leg shot is a different pose. Okay, but when it comes to here, it will understand. When I train the model here, it will show this is jab, this is punch, this is leg shot. Okay, but when I'm importing my own dedicated, I could third party model or Ina's own model like which is completely designed for boxing. Okay, so I could call up the model here. So when I run the teachable mission with through CAM, so it's like in the behind the scene. Not only it will showcase my jab position or punch position, it will even give more prediction accuracies like my jab is this much speed and my jab is lower speed, or my ankle wrist is like not in good position. Okay, it will give conditions. So we could analyze and train like this.
Okay, very good. Okay. So teachable machine and Hugging Faces is where Hugging Faces is a portal where you can get more trained models.
Yeah. This is like supported for our train models. So you could find anything that you want. You almost got to achieve everything. We can build it for application in the market.
Very good. Okay.
So we have seen a lot of some people will be building that Instagram video downloader or somebody PDF to Word converter. Okay, if somebody wants to create something like this on their own, they could easily understand the paperwork of here multi-model documentation. So we can find a models here. If we know quite coding, and we could easily design those models and train it up there.
Okay, good. Okay. When did you start learning about all these things? When, how many years ago did your journey into AI started?
It's been 2018. Okay, in the where during the time it's a new for Python. Python is actually in the beginning stage of adapting to AI. Okay. So where it was exactly Python 2.7. Okay. No, it's actually Python 2.4. Okay, during the time, every 2 months, it just amazes me when I'm starting on 2018 Feb, where I'm doing my for loop. I'm building a for loop function. Okay, during the time I was writing 4 line. After 28 days, the new Python package has been introduced, 2.4 to 2.47 or 8 or 2.5 so on. Okay,
Okay.
and then after my 28 days, what I've written for loop code, and it has become 2 lines of for loop code. Okay. Then
Okay.
after another 2 months, that the 2 lines of for loop code has been changed into 1 line of for loop code. And then like another after 1 month, and they introduced something called lambda function. Okay.
Okay.
So within 1 line, you could write a for loop condition, and as well as you could write a if and else condition
So
under the
you are
for loop
saying that
itself.
Python was rapidly changing. That's what you're saying.
Changing during the year time. So like it was easy.
Okay.
During the time, like PyTorch, like PyTorch was famous.
Mm.
Okay, there was no TensorFlow. So during that PyTorch time, where we need to build all the mathematical key points for
Okay.
all the data sets while we training the data, and there was we write a lot of conditions inside the Jupyter notebook or
Okay.
Python interface IDE.
You say you started in February of
18.
2018, right?
Yes.
When were you able to understand
It
all
took me
these
nearly 1 year.
algorithms?
So
Okay.
it really took me 1 year. Okay.
Okay. For you to be able to play with these algorithms.
Yeah, to play with
Okay.
these algorithms. So
Okay.
first 3 months, I was more conscious on my Python skills. Okay. And then data structure, the more you understand the data structure, the more you can write any functions that you want. Okay. So here data structure part like plays a big role, so that you could write a conditions for filtering the data. So you could write
Okay.
your own functions and methods, so on.
Okay. Is that a one-off, like teaching machines? Is that becoming the norm that people don't code, they just use these kind of packages to drag and drop? Or is it just a one-off
No,
for a easy learning? Teachable machines will tell you how things are happening in the background.
teachable machines, it's like if we going for a corporate and corporate application, you could see Viso.ai. Okay, these guys are the best in computer vision applications. Okay, they run the integration part and so on. They have wonderful resource here, so anybody can do the. You can also train your life skill train data on self-driving car.
Okay.
Okay, and like a lot of things you can we can do under the computer vision here.
Okay, good. I think I'll leave for others if any other questions are also there.